Okay guys, in this video segment we're going to talk about the rules for rounding significant figures when we're doing mathematical calculations with that. Now within this system we actually have 4 different rules to follow. Of those 4 rules, the first 2 are really the core rules, and the second 2 are just kind of helper rules to help us out in terms of some unique situations. So let's start with our first rule. The first rule deals with multiplying and dividing. So the rule tells us that answers for multiplying and dividing measured values should have the same number of significant figures with the least number of significant figures from a measured value. Okay, so if we do a practice problem with this, we'll walk you through and show you what we mean by this. Okay, so if I have, let's say I want to solve for a density, and we know density is mass divided by volume. Let's say I measure the mass of something to be 28.2 grams. And then I measure the volume of my object to be 2.3 milliliters. So we have 28.2 grams and 2.3 milliliters. Now those are 2 measured values. So our first step here is to figure out how many significant figures does each number have. Well, my top number, since it has 3 non-zeros in it, has 3 Sig Figs. My bottom number has 2 in it, or 2 significant figures, which means if I have 2 versus 3, 2 is my smaller number, so my answer, when I actually solve this, will only be able to have 2 significant figures in it. Okay, so if we actually go through and solve this one now, so 28.2 divided by 2.3 gives me this dumb calculator answer of 12.260869557, and it doesn't even label it for me. So what I want to do is take this answer and then round it to 2 significant figures. So here's my first, here's my second, and then we look at this place right here to determine if I'm going to round this up or round this down. So because this number is less than 5, I'm going to round this down. So my final answer would be 12. And of course we want to label it grams per milliliter. Okay, so what we're doing is, when we're multiplying or dividing, we look at all our measured values, figure out how many significant figures are in each measured value, pick the one that has the smallest number, and match it to our answer. Notice how this is out to the tens place and tens place, but my answer does not go to the tens place because we only had 2 significant figures here. So it is not lining up the precision of what place your decimals go to. It looks at the actual counting of your significant figures for multiplying and dividing. Okay? So that's rule number 1. Now rule number 2, when we take a look at it, this is for adding and subtracting. When you add and subtract, we do not count significant figures. Instead, we look at the process and say, where is the least precise measurement? Okay? And we round it to that point. Now typically in adding and subtracting, if you're using the same tool, so if you're using the same ruler for all your measurements, that's easy to round because it'll just match up to the precision of your measuring tool. However, if you're in a scenario where you're going to have different values that need to be added up, which can happen in the different sciences, then you have to worry about actually rounding these values off. So let me show you an example of that one. So if let's say I take, I have 1,100.1 grams of something. Okay, I'm not sure what that would be, but that's what I have. And let's say I subtract away 10.0 grams. So if I do my normal math, 1 minus 0 is 1, for my decimal, 1 minus 0 is 1, 1 minus 1 is 0, and then I have 3 ones left over in this. So this measurement, if we look at it, the last measured value falls in the tenths place. For this value, even though it's zeros, those zeros are measured if we go back to our rules for counting significant figures. So this is measured, measured, measured. So this one also falls in the tenths place. So if that's the case, my answer should then be rounded to the tenths place. So my answer, we'll leave it as 111 0.1 grams. That would be my final answer. Now let's change it a little bit. So let's say instead of having that, let's say I just subtracted away 11 grams from this, not 11.0. Now, if I do my math, I have basically 0.1, and there's nothing here, so it's still a 1. And then 1 minus 1 is 0. 1 minus 1 is 0. And I have my extra values out there. In this case, because I'm subtracting from, the ones place, so the tens place is still true here, but now the measurement of the other number ends in the ones place, my answer has to be rounded to the ones place. So I have to round it to here, which causes a little bit of a problem in this particular number, because if I round it just like this, and I'm done, that 0 would not be identified as being significant. So a way we work around that is we actually leave the decimal on, but we don't put the plus 1, the 0.1 on there. So we round it here, and because this was a 1, we're rounding in this position right here. Because this is a 1, we round down, so we keep it a 0. And we leave the decimal on to tell everybody that this 0 is actually part of a measurement. Okay? And of course we label it grams. So that is your adding and subtracting rules. So for rule number 3, it's actually a combination of what happens when you have both multiplying and dividing and adding and subtracting in a problem, which does happen in some of our different examples in the chemistry class. So I'm going to show you an example problem. What do you do when you have mixed rules going on inside your problem? And what we're going to do is we're going to set up a simple weighted average problem that might be used for solving for atomic mass or something to that extent. So for example, if I have magnesium, and magnesium has 3 different isotopes to it. So we could have magnesium as a mass of 24, magnesium as a mass of 25, and magnesium as a mass of 26. So these are all different mass numbers for the magnesium. The percent that magnesium 24 is in our world is 78.99%. And the percent that 25 is only 10%. And the percent that magnesium 26 is 11.01%. Now, within this problem, percentages are measured. So they will factor into our significant figures. These mass numbers here, they actually come from something that is counted. So they will not play a role in our significant figures here. But I still need to do the math to figure out what is my overall atomic mass of this substance if I average out all 3 isotopes. So if I do the math, I'm going to take 24 times this, 25 times this, and 26 times that. But when I get these 3 answers, I get, I'm going to have to add them together to get my final answer. So I'm going to have to first multiply, and then I'm going to add. So I have 2 different rules to work with. So the way we solve that is anytime you switch from one rule to the next, you round before you make the switch. So 24 times 78.99 is 18.9576. 25 times 10% is 2.5, and 26 times 11% is 2.8626, I believe. Let's check it. Yeah, 2.8626. So here's my values that I have, taking this number times that. Now in this problem, because this is counted, they have an infinite number of significant figures. So my only really measured values to look at are here. So I have 4, 4, and 4. So I have 4 Sig Figs to work with, which means my answers for each of these cases has to have 4 also. So 18.95, this is my 4th measured value. This is a 7, so 7 means I have to round up. So I'll round my answer at this point to 9.6. 2.5, well that number only has 2 significant figures in it, but I need 4. So I'll actually add 2 zeros to this so I have the correct precision of having 4. And then 2.8626, again, I need 4. So there's 1, 2, 3, 4. And that's a 6, so I need to round this up to a 3. And now, since I've rounded these properly, I can then move on to finish my problem. So I'll add these up. So 3 plus 0 is 3, 6 plus 6 is 12. I get 9 carrying the 1. So that's another 3. And come over here. There's a 2 there. And this ends up being a 4 and a 2. So I end up getting 24.323. But I was adding numbers, so now I need to round these properly. Again, I go back to my measured values, which these values come from these measurements. So because I'm adding and subtracting, I now want to find the precision of each measurement. Where this one ends in the hundreds place, this one ends in the thousands place, this one ends in the thousands place. So because this one ends in the hundreds place, my answer has to be rounded to the same spot. So then, because this is a 3, I'll round down, so my final answer will be 24.32. And measurements of this case are actually measured in something called AMUs, or atomic mass units, so we'll label it that. Okay? So again, don't worry so much about the chemistry side of this. Look at the actual math in terms of the significant figures here. That's our focus today. This was a counted value, so it had infinite significant figures. These were measured. They each had 4 significant figures. I had to do the multiplication first and then round each number appropriately before I could add them. Once I had them rounded properly, I looked at the precision of each of my measurements. This one ended in the least precise location, so I had to round my final answer to that location, which then gave me 24.32. And of course, I added the proper label to my answer. Now, rule number 4 takes a look at what happens if you do not switch rules. And if you're not switching rules, that's actually easier. Because when you don't switch rules, you do the problem in its entirety until the very end and round at the end, which is pretty common practice in most of our math classes anyway. So again, multiplying, dividing, you count sig figs, match it to the lowest. Adding and subtracting, you don't count sig figs, you look for precision, match it to the lowest. When there's multiple rules, you round between rules. And if there isn't multiple rules, you do not round until the very end. All right, guys, that is it for this quick tutorial on the rounding for adding and subtracting, multiplying and dividing.